What comes to mind when I say the word energy? Energy can come in many, many different forms, on both the large scale and the very small scale. This video will focus exclusively on the most basic forms of energy in the physics world, which it turns out give us some of the richest insight into the motion of objects. Kinetic energy, the energy of motion. An object in motion must have a velocity, and an object with a velocity possesses kinetic energy. It's an intrinsic quantity of a body. The way we change an object's energy is very simple. We do work on that object. That's force times displacement. We can further break force apart into mass times acceleration. From there, we write acceleration in a more calculus-friendly way, change in velocity over change in time. We can then write change in displacement over time as velocity. Rearranging a little bit, and we have an ideal equation to integrate. Integrating with respect to v will give you the equation for kinetic energy with which you're more familiar. But we can perform work in other ways as well. Namely, we can perform work against what we call in the physics world fields. Any massive object creates a gravitational field. Unless we do work to overcome Earth's gravitational field, we are stuck to its surface. So let's do work on a body, and in doing so derive clearly what potential energy is exactly. We want to do work against Earth's gravitational field. Work is force times displacement. Force can again be broken up into mass times acceleration, but our acceleration is g, since we are close to the surface of the Earth. We integrate with respect to displacement to get our familiar equation for potential energy. We see from the equation that potential energy depends on a given height. What this means practically is that it takes work exerted through a height to increase the potential energy of a body. We've covered Earth's gravitational field. Let's move on to something less intuitive. Voltage. Consider a battery in its simplest form. A battery is a dipole, a cell with a positive and negative end through which charges flow. A voltage is created when we have a difference in charge over a given area. It is for this reason we sometimes give voltage the name potential difference. We can consider the space in between the two dipoles to be a kind of electrical height. When negative charges pass through this height, they gain energy and can readily flow through a circuit from the negative to positive end. Say we want to move the charge against this field we've created. We know from our gravitational field derivation that we must perform work to move against a field. However, we come to this conclusion much more intuitively because we can approach this situation with prior knowledge of Earth's gravitational field. Hopefully these short derivations have given you a more concrete understanding of energy and voltage. Thanks for watching.